for preparing everything for today. And yeah, let me know if anything. I'll just remove my video so that you have the main stage for you. And if you need anything, just let me know. All right.
All right. So what I'm gonna do is I'm gonna share my screen now. So can you see my screen, guys?
Yes. Yes. Yes.
Okay. Cool. Awesome. So in this call, first let me introduce myself. I'm Sam Zhou. I'm the founder of OnFinality. Also, we have Yan in this call as well. He is the CTO of from OnFinality. Today, what we're gonna do is, basically our mission is to support blockchain developers, especially the Substrate developers, by providing infrastructure service to customers of all shapes and sizes, right? Today's agenda. So firstly, I will quickly talk through each of our different product stack, the dedicated node, public API services, DevOps solutions, and the SubQuery network. Then both myself and Yan will demo each of these products. And then last, we will do some Q&A. Okay, so this is the agenda today. First, dedicated node. We provide one-click solutions to create dedicated nodes and support both full nodes and validator nodes. With Rococo is live, we are supporting collators as well. So you can automatically deploy and scale your production infrastructure across multiple cloud hosts using our CLI toolkit or web apps. When we deploy your new node, we will provision it with snapshot backup, so your node doesn't have to sync from block 0. You will have your full node almost straight away. Of course, it will depend on the size of your chain. My platform also provides some monitoring of your node in the UI. Public API services. We provide a free API services that allow users around the world to access our managed share nodes in the Substrate and the Polygon ecosystem. Our platform provides detailed logging and analytics so that our customers can see how their users are using their dApp. Additionally, we also provide the builders of the network themselves with the data on how our API services is being used for their network. DevOps solution. So OnFinality offers simple yet powerful API and a CLI toolkit that allow blockchain development teams to easily create full Bootstrap networks in a matter of minutes. A team can provide their latest Docker image. We will deploy the changes to a brand new testnet. Teams can script entire network creation using our CLI toolkit, then monitoring the health of their network. Once they don't need the network, you can easily remove everything with the CLI toolkit as well to save time and money. SubQuery network. Almost every blockchain has a need to process and query data. The Graph is an Ethereum project that allows customers to do this using GraphQL. We are building a similar product for the Substrate and Polygon ecosystem. Our aim is to make this a core piece of infrastructure for Substrate and the Polygon ecosystem, just as the Graph has become for Ethereum. We have 3 stages development plan. First stage, SubQuery node, which is an open source project and also granted by Web3 Foundation. Thanks for the grant. In this stage, developers basically can set up everything in their local environment or their own hosting environment. We will fully deliver this open source project in 2 weeks' time from now on with the detailed reporting and testing. Our second stage is to build a hosted service. In this stage, developers develop their own SubQL project or components and submit it to our hosted service. Our hosted service will create indexing and querying service to service the application. Our final stage is to tokenize the SubQuery project by building our own chain, likely Parity for Polygon in the future. So let's move to the demo. So here is our website. In the website is API service dedicated node and infrastructure. So it's free to sign up with your Google account or GitHub account. So if you have if you already register, then once you log in, here is your dashboard. In the dashboard, you see 4 menus: dedicated node, API services, network, and settings. Also in here, you can switch different different workspace. If you work on multiple projects, it's better to create multiple workspace. Then in here, in the account, basically you can set up your name and an email address, password, because in this case I'm using the OpenID login, so you don't have to change the password. Access key basically is for our CLI tool, is just manage the authentications. Also, you can redeem your coupon code, buying your credit card, to download all your old billing histories in the platform. Then let me introduce the dedicated node. In the dedicated node, basically, you can create the protocols the platform supported. Currently, our platform support Kusama, Ethereum, Polygon, also. It's so big, and the majority of the top Polygon ecosystem protocols. So when you create, for example, Kusama node, dedicated node, it's just I gave a name, my test Kusama. Then you choose different cloud providers, AWS, GCP, or Google, or Azure. Azure is going to come in soon. Then you choose a different region. In this case, I choose Tokyo. You can choose different node configurations, small, medium, or large. By default, we give you the recommendations in medium size. Medium size is a 2 CPU from my memory. Then the storage size is 20 gig. Then you go to next. Then give you some node summaries, then you create a node. Then you back to the list, you will see my test Kusama is processing. It normally take probably up to 20 to 30 seconds to boost to provision your full node. Once it's provisioned, basically you can go to the details of your node. Then you can see all the details like your node type, cloud provider, all the details and the CPU sizes, memory, and the storage. Of course, you got RPC endpoint, RPC endpoint, and the WebSocket endpoint. With this RPC endpoint and WebSocket endpoint, you can use straight away. You can configure it in the Polygon.js, to just configure the endpoint, it will work straight away. So this is our dedicated node services. See the status currently initializing. The next status is running. It might take another 10 to 15 seconds, just leave it running, don't worry about it. In here, you can see in our UI, actually, we doesn't support different node type, but actually in our CLI toolkit and the APIs, platform API, you can create validator node and the full node, different node type. So later on, Ian, he's gonna demo you how you're gonna provision Rococo validator and a Rococo like a collator. So this is our dedicated node. Then we move to on the API services. Currently, in this page, you see our API services. We support 3 public protocol, Kusama, Polygon, and Rococo. You see the Kusama, each API protocols have different RPC endpoint and WebSocket endpoint. Then you can switch between different protocols. So basically, we can add as many as Polygon substrate protocols in here. Then we provide basic statistics, request the daily request statistics. Also your usage, you can switch between different usage, because at this stage we don't have a quite a lot of usage in this particular workspace. So there's no statistics. So let me quickly switch one workspace, like this Parity one. From my memory, it has some Rococo usage. Let me take the last one. See, that's the usage. This is the real-time usage, right? So this is the API services. I'm gonna quickly go to our Grafana dashboard. This is our Grafana dashboard to monitoring our API services. you see right now we have 2 Ethereum node and 3 Polkadot node, 3 Kusama node, and Akala node, or Rococo node. Currently, we have 230 different like gateway connections. Then we have today's request. You see the total request 2.5 million requests so far. And yesterday we have total 5.5 million requests. Polkadot alone got 3.5 million requests for yesterday. Then we have a different, like, where those requests came from. They came from different IP address. We can, to give the different geolocation where this request came from. So this is our Grafana dashboard. We can monitor the health of our pool and our node. So this is our dedicated the API services. Then the next, what I'm gonna do is I can quick run through what the CLI tooling. So I'm gonna, because it's gonna take a long time. So what I'm gonna do is I just run through this video in order to save time. So basically in our repo, in our OnFinality repo, you can see a OnFinality CLI tooling, which is the open source, everyone can see. Let me quickly play the video. So in the CLI tooling, OnFinality CLI tooling, you can download the binary. So our current version is version 2.0. You just download it, whatever the version you need to download. Then in this case, I'm using Mac. So I just download the Mac version. Once I download it, I'm gonna rename it to a shorter name. Then I'm gonna open my terminal. From the terminal, because it's an Apple computer, it gotta have a lot of security settings, right? So I just grant the permission to my local computer, local Mac. So let me quickly run through that command. So that command is gonna give make the binary executable. Then I'm gonna run this time gonna be give the Apple permission. By the way, we are working on the with the Apple like a signer, which means once we sign our binary, you don't have to go through this process anymore. Then remember the access key from our platform. So in this CLI, in this command, it's asking for the access key. So basically, you can generate a new access key. Put the access key into the command lines. Also the secret keys into the command line as well. Okay, then we're gonna run the command. That command is a Bootstrap the Testnet based on the configurations. You see, we have Bootstrap config JSON file and a spec JSON file. We provide these two configuration file in our sample repo. The sample repo basically, in our like open source repo. Then we can quickly look through what those configuration file looks like. So basically, from those configuration file, you can specify how many validator you need and by which image, what the node size, and which cluster you want to deploy, and which cloud provider, GCP or AWS, you want to deploy. Also, you can bind in the session case into the configuration file as well. So basically, it's a basic template. You can add in more parameters into the configurations. We are working on a full tutorial, like articles, on how to using these CLI tools. Because right now the development is done, it's lack of help file. We are working on the tutorial files. Then, once the command is run, you see that first it's gonna generate a chain spec, we'll call it like a chain definition file or network definition or network specs. In this case, it's sample testnet. This sample testnet with four nodes, 3 of them is validator, one is bool node. No, 3 is bool node, 1 is validator. It really depends on how you config with those 2 configuration files, the Bootstrap config and the GenSpec configuration file. It really depends on, it's fully customizable. Okay, so this is how you're gonna bootstrap your testnet with our CLI tools, because it can take a little bit of time, to bootstrap. So I just quickly go through the result, then to save time. By the way, this YouTube video basically is on our OnFinality YouTube channel, so everyone can see it. See see the final result is we have 4 nodes is running, it's all running with these configurations. Here you can see all the details, blah blah. So So okay, this is the the demo for how to using CLI toolings. So what I'm gonna do is I'm gonna pass the next demo to Yan. So he's gonna demo how to create a Rococo with the CLI toolings, and also he's gonna run through the SubQuery node. Okay, all right. I'll unshare my screens. Stop sharing. Yan, it's your turn now. We cannot hear you.
Yeah, you're muted, Yan.
Oh, yeah, sorry. Hi, everyone. Yeah, I'm going to demo our support for the Rococo and the parachains. Yeah, let me share my screen. As Sam has mentioned, from our web UI, we allowed user to create. So you can see Rococo is already listed there, and user can create 4 nodes of Rococo. But in case you want to create validators, it is also supported through our CLI tools. So on my local, I have already logged in my account. So set up my access keys and secret keys. This is a simple config file required to start a validator. You can see I put a node name, node spec, specify the cluster. Yeah, and most importantly, the node type is a validator. Then you can use the create command and give it this Rococo config. Okay, the command tells the new creating node it's successfully created and the node ID. So you can use the command line to check the status of the node. Yeah, it is like initializing, and also you're going to see it from the web UI. And the node name will be the same name registered in the telemetry. Yes, that's it. But once you have the validator, you still want to run your run collate of your own chain. So we also support that. But we know that so in the current stage, most parachains they are under development. So those parachains they are not going to list it publicly for every user to see it. But you can create a network spec for your parachain under your own workspace. Again, I prepare a config file to create the parachain. I will use a Rococo tick parachain, for example. This repo is, so I forked the public code and published the image to our own Docker Hub repo. So this time we are going to use network spec crate. Because this is a user-created network, the key will be a hash string instead of a human readable name. Now we just going to need the network key, and there is another config file to run the collator. And I'm going to replace the network key with this one. So yeah, this time the node type will be a collator. And you can also choose for node if that's what you want to create. Then it will be going to it's going to be the same command to create the collate of tick. Yeah, this is our new created network spec, and a collator is processing. So once it's running, you can connect to it using the WebSocket endpoint. You can connect to the node. I think this node is still syncing. It should be very fast until it is fully synced. Yeah, that's it. We're still like it's under heavier development to get more support for the Rococo chain. Then later, I'm going to demo you the SubQuery project. SubQuery is for the open source toolkit. It is open sourced under our OnFinality GitHub organization. Today I'm going to demo that using a test runtime, test network, which is a Kitty NFT runtime. Let's first spend some time quickly go through what this chain is about and what feature it supports. This example, I took it from the Substrate runtime academy. This is their assignment 5. So you can see there's a kitties palette. The palette allows user to create kitties. So first there's a create extrinsic, which will randomly create a kitty with random DNA. And one of the DNA decide the gender of the kitty. So you can see the gender is decided by the first byte of the DNA. And then the extrinsic allowed owner to breed kitty. So given 2 kitty with different gender, you can create a new kitty. And also the runtime allow user to transfer the ownership of a kitty to another account. And all of those extrinsic will create events. So you have a Kitty created events, Kitty bred events, and transferred events. The storage for this runtime is so the kitties. It is a double map. So that means if you want to query a kitty, you have to give you need 2 parameters. The first one is the account ID which is the owner account ID of the kitty, and the second one will be the index of the kitty. I'm not going to discuss like why the storage is designed this way, but sometimes there will be a reason, like there will be a compromise. So it's a decision between the efficiency, the performance, and the convenience for query. But yeah, for this chain, it's like this. So what happens if you want to query a kitty, but you only know the index of the kitty? So you want to query who is the owner and like if the kitty is created directly or it's bred by 2 parent kitties, and who are his parents. So these kind of things. It's not going to be a like straightaway API query in this case. To solve that need, that comes to our subquery. So I create an example for this kitty chain. First, I need to define the project, give it an endpoint, and the custom types required so the API can connect to the chain. Then you need to define the schema. The schema well, it's not the schema defines like the table. So how you want to structure the database. Yeah, I'm going to show you from the GitHub. Schema. So in this case, yeah, I create a kitty birth info entity. The ID will be a kitty's ID, and then I will record. I will store the birth block height of the kitty and the owner. So current owner and first owner, and if it is bred by other kitties, then it will store the parent kitty, parent kitty's ID. Then to achieve that, you need to define the mapping functions. So there are 3 mapping functions required here. The first one handled, so when the kitty created event is received, you can see it is defined here with a filter. So it is an event handler with a filter, so module kitties, and the event name is kitty created. When a kitty is created, we create a new record, extract the owner and kitty ID from the event data, and store the block height, first owner, and save the record. The second one is kitty bred. So it will be a little bit different from the first handler because we need to know the parent of the kitty, and the parent can only be extract from extrinsic argument. So that's the reason we will use a call handler here. With call handler, you get the extrinsic as well as all the related events of the extrinsic. So in this case, I will filter kitty bread event. So I can get owner of the kitty and the kitty ID. And I can also extract the parent kitty from extrinsic argument. So I can set parent and then store save the record. And the third handler is similar. So it's simple. You get a kitty transfer event, and then we can update the record with the new kitty owner. So when all is done, you can build the project. Then we provide a Docker compose file, so it will start everything, start the database, the SubQuery nodes, which loaded with our SubQuery project, and Kusara to help user query the data. I'm going to remove the data of my last run. Yeah, I'm going to start the node locally, run it under dev and temp mode. Yeah. So as you can see, I've connected to my local node. Then I'm going to create a few kitties using Alice account. Because the gender of the kitty is randomly assigned, so I will create a few more kitties in case I got quite bad luck. Yeah. Then we can try the breed. Yeah, let's see if they. Okay, cool. So the kitty 0 and kitty 1, they are of different gender. We can let them have more baby kitties. Yeah. Then I'm going to transfer some kitty to a different account. It's totally depend on you. Okay. Now let's run our subquery. Yeah, it's going to take some time because the first time to run it, so Postgres will spend a few more seconds to create a brand new database. Then the subquery node can connect to it. And now you can see it's start syncing. And we can connect to the Hasura. Starting Hasura. Okay. Yeah, we just need to track the Kitty birth info table. Yes, then we can query kitties. Like if we want to see the serial, give it the ID, we can see the owner, the first owner of the kitty. And if we try a different, so one of the kitties, like this one. So it is a so it has parents. So we can find the parents from the data we've indexed. Cool. Yeah, that's everything I'm going to demo today. Then it will be the question time.
All right. Thanks a lot, Sam, Ian. Thank you both for everything that you showed us today. It was very interesting. There's a couple of questions in the chat. So Jacob had one. He's basically asking what kind of nodes are you running that quite high requirements for CPU single core speed. We found that there's not many cloud providers that have something like i7 7700K. I think that was the popular node requirements. Do you also support secure validator setup with Sentry nodes and a backup node possibly?
The node spec we public to the normal user, it is small, medium, and large. It is the large node is you can see from our UI, it is 1.5 cores. But for our partners, we give them more flexibility to create a higher spec node. Yes, the next question.
The next question is asking for the security validator setup on the Sentry node. We used to have our API to support the Sentry node setup, but based on my understanding, like they have they don't need the Sentry node setup anymore. So probably our platform doesn't need to support that feature anymore.
Yeah. There's a parameters to create a node, which is an API key. So for the validators we created, it is running in with the RPC method unsafe. So you can connect to your own node and set like rotate your key and set the session keys. But for so it is protected by your API key. So yeah, when you just need to keep the API key safe, then other people won't be able to connect to your node.
Okay.
And if I can jump in 1 second.
Yeah.
The Sentry node setup was actually deprecated, I think on 0.825 or something like that, in regards to the requirements for parachains connecting. Because parachains are connected and they want to coordinate with the validators, getting the global validation or consensus or validating from the POV, from the proof of validity blocks from the collators. It is pretty hard to route that traffic through to the validator through Sentry nodes, because you would need to know what Sentry, like what validator is protected by what Sentry, and then route that traffic through that Sentry node to the validator. And as far as I know, I'm not 100% sure on that side, there were like changes in the peer-to-peer protocol on how those nodes get validated, those connections from the multi-address get validated in order to stop DDoS and all that stuff of attacks. And by that change, the Sentry node requirement got deprecated. Just as a side comment in that sense of the Sentry node stuff.
Okay.
Yeah, I'm going to add some more, maybe. So there are few advanced usage of our platform. Like you can see, we have a P2P endpoint shown here. for some nodes, like we show a public P2P and internal P2P, and we allow user to pass extra command line arguments to create nodes. So when advanced usage will be, you can create a few nodes, and then you can create a node like your validator. You can use reserve nodes and restrict your validator only create the nodes of your own. If they are all created in our platform, you can use the internal P2P address. If they create like across different region of our platform, then you can use the public P2P address. Yeah, that's just an advanced usage of the platform.
Okay, cool, thanks. There's also a question, William, that's asking you guys, like, what are your plans of expansion in terms of regions? Because right now it's only Asia-based. So how does that roadmap look like?
Yeah, that can be our next milestone, because currently in our production environment, we only got 2 clusters. One in Tokyo, Japan, with the AWS. The other cluster is a GCP, also in Asia Pacific. So we are planning to build another 2 clusters. One is in Europe, the other one is in North America, to cover global access. So, but that's our next milestone. Actually, we want to do it in the we want to implement like intelligence routing, which means, based on your location, we're gonna servicing your request with the closest like a cluster to better, to improve the performance. That's the next step we're gonna do.
Okay, thank you. William, is that enough for you, or you got any other follow-up question there? Okay, perfect. Thanks, William, for that. I think I've got a question from my side, and that would be, if any of the builders have any questions, who should they be reaching out to?
So sorry, the line wasn't clear. So now, can you repeat it? Suddenly lost.
It's all right. If any of the builders have any questions, who they should be reaching out to?
Either I just noticed, like, currently James Bailey in the call as well. So basically James Bailey, he is in charge of our marketing and the relationship. So they can either approach myself or James or even Ian. So we all are approachable. So 3 of us actually in the builder channel. So so they can approach us directly.
Okay,
hi everyone.
That's very good. Hey James. Does anybody else have any questions for the OnFinality team? All right, then I guess that would be all. Thank you guys very much for this. It was very, very interesting, and I very much hope that a lot of teams in the Builders Program start using your solution. That would be a very nice experience and ecosystem cooperation overall that I would like to see. But thank you for your time. And if anybody has any questions, you know where to reach them out on our builders channel. They're all there. Okay. Okay.
Oh,
so I think that will be all.
Thank you so much. Thanks for having us here. It's really a pleasure and honor to show our products here. So hopefully we can all grow together. Hopefully our products can benefit the rest of the builder team. If that's exactly our intention.
Yeah, that sounds very good. Thank you, Sam, for that. Thank you, Ian, as well, and James, and all of you that joined. But that will be it. So hope you have all of you a very good day and a good night for you that you're based on Sydney in Australia, and I'm sorry, on New Zealand, not Australia. And yeah, I guess we'll see you all around. Have a good day.
Okay, cool. Thank you. Have a nice day. Okay, bye.
Bye-bye.
Bye, everybody. Have a good one. Talk to you.
Bye.
Bye.